Welcome back. Here I am. New lesson today. We're going to deal with graphing a function, and it doesn't have any numbers in it this time. It's called the natural base exponential function. We're going to graph it and do a transformation. So it's new, but it's not going to be too crazy. So sit back, relax, and about to get schooled distantly. Happy Friday. So the first thing we're going to do is we're going to graph y equals 1 plus 1 over x to the x power. We're going to notice that as our x's increase by the hundreds or 200s, they get closer and closer to a value. This value being approximately 2.7183 if we round it. That is what we know as E. All right, here's my makeshift whiteboard for us. So we now have this thing we are calling E. And E is approximately 2.7183. So that's what E is. Now, what we're going to do real quick here is make a little table of X's and Y, but our Y is going to be E to the X power. So E is our base. So if X is 0, 1, 2, or 3, we want to figure out what it is we get for our output, our Y value. Well, if X is 0, E to the 0 power, anything to the 0 power we all know is 0 exponent rule tells us 1. Now, if I put E to the first power in my calculator, I'm going to get approximately 2.7183. I'm going to round that to the nearest, 10,000th? If I put a 2 here, E squared. E squared. Well, if I know what E is, I want to square this. So this times itself ends up being approximately 7.3891. And I can keep going. I mean, if I have a table, if I've graphed it, use decimals, whatever it is, I put E to the third power, I look at my table, it's this 2.7183 times itself again. So we approximate that to be about 20.086. So my emphasis here is that E is a value. And it's on your calculator, and I'll show you in a minute here where you can find that. But it is irrational. So part of our notes here today will be determining an irrational and a rational number. So E is irrational. These decimals never end. I can't write E as a ratio of some number over another number like a fraction. It's non-terminating, non-repeating, so E is irrational. So on your calculator, or on decimals, they have the E button there, but on your calculator where that arrow's pointing, that is the E to the X button, your natural base exponent. So if I hit that button and then the little box will pop up, I can put a 1 in there, I hit enter, and it'll give me that 2.7183 approximately if I round it. So it's the button just below the caret that I use to put any exponent in, but there it is on my calculator. It is an irrational number. In your books on page 337, I know you don't have your books, but you can get them through Clever. Again, that's page 337. I'm going to show you kind of what we're looking at here now, which is graphing these and transformations. So if I know how to put E in my calculator and get a table, I should be able to graph it. But here at number 4 on page 337, because I know someone wasn't listening, the parent function here is E to the X power. So that's my natural base parent. Remember, my base tells me the parent. E is my base, so my parent is E. And then I'm going to graph the function g of x by correcting the correct vertical stretch, shrink, reflection over the x-axis, or translation. Then we're going to write that description. So f of x is E of x. So I can see that that graph that is going up to the right, that's the parent function. Just like all our exponential growth, it goes through the point 0, 1, because when x is 0, it's going to give me 1. And then when x is 1, I can see that that roughly goes through that 2.7. I'm losing my pointer tool. Bear with me. When x is 1, roughly 2.7 right there. And I can find some other points as well. Now, to do the transformations, I need to remember my C bad. Well, I don't have any C up there. I have no B, so I have my A. So it's a reflection negative. So everything gets reflected. So that's why it's going down to the right. And then half means everything gets stretched. So instead of going here, this point gets reflected down to -1, and then it gets -1 times a half is a -half. This 2.7 roughly gets reflected to a -2.7, and then half of that gets reflected down to there, whatever that value, -2.7 is going to be, what, roughly -1.4. And so I can see that graph G is a vertical shrink, or it's a vertical compression by a factor of a half, and it's reflected over the x-axis. The domain shouldn't change. The domain should be all real numbers. The range, though, I can see that one is going from 0 to infinity for my original parent function. And then the range for g of x is now going from -infinity up to 0. So again, where that reflection is over my asymptote, where y equals 0. So the asymptote hasn't changed. It's right there at the x-axis. Let's look at example B here. So again, parent function is e to the x power, and then we have our transformations. So my c bed, well, if that's -4, c is always lying, so I'm going right 4. So that 0, 1 is going right 1, 2, 3, 4. But then the d is up 1, so there we go, up 1. So now I have a point at 4, 2. So everything else is going to go right 4, up 1. So we can tell where the asymptote is now. It was at y equals 0. Now it's up here at y equals 1. But they're both still increasing up to the right. So I know that this graph transformed this g of x by going right 4 and up 1. And I can see that here. It's a horizontal translation, right 4 units and up 1. The domain, still all exponential functions, all real numbers. So from -infinity to infinity. The range of the parent function, well, since it's a parent, it's going from 0 to infinity, or y is greater than 0. And the range then, since I moved the asymptote, goes to 1, but I didn't reflect it, so now 1 is the asymptote. It goes up from 1 to infinity, or y is greater than 1. And again, your asymptote for the parent function, y equals 0, and for the transformed function, the asymptote is at y equals 1. So some notes, as you can see, these are back from 2019, February of last year. But natural base exponential function. What is a natural base exponential function? We already wrote that. That was our e is equal to 2.7183. So you should know that. This kind of just breaks down, what is a rational number? A rational number is a number that can be written as a ratio of two integers. So if I can write it as a over b, where b is not equal to 0 and a and b are integers, then that's a rational number. E is not rational, so I have to remember that's an irrational number. And an irrational number is a number that cannot be written as a ratio of two integers. Something like pi, or some of our radicals, the square root of 2, doesn't lend itself to writing as a rational number of two integers, and a ratio of two integers rather. And the cube root of 3. So these are non-repeating, non-terminating decimals. That's why e is an irrational number. And so if you have a base, b is your base, raised to a power, that's your exponent. So now our natural base is e. E is your natural base. E to the x power is the natural base exponential function. And so it has a value. It's not a value I can write simply. And so we use e just like we use pi, because I can't write all of pi because it's irrational. It's non-terminating, non-repeating, similar to e. So as I promised, it wasn't too difficult. It wasn't too hard. I'm going to assign you some problems from your Springboard book. You can get to it through Clever. I'll post that as well. Or I'm going to put the screen caps of those problems for you too. So if you can't get into Clever, have troubles, or just want to be lazy, I'm going to put them included with all this stuff. There will be a little assignment here. So these are practice problems to see if you want to practice it, go through it. If you're lucky, maybe I'll post answers or ask questions, and I'll be like, oh yeah, here's what you need to do, here's how you do it. It's going to be being able to graph that natural base exponential parent function, e, and then transforming with it, which really doesn't change anything from what you should have been doing and what's due Sunday night, with just regular transformation stuff from that worksheet and just identifying them. Again, graph the stuff on Desmos, graph it on the, I know I put a link earlier this week or last week for TI. I was given free calculator, so if you want to get that app for your Chromebook, I don't know if it'll work on there, but I know you'll be able to put on your smartphones if you want to have that, and it's good for 3 or 6 months, I'm not sure, but that's nice to have. But I'm going to assign these things, and then there will be a homework quiz. So a few questions, just kind of seeing, are you understanding what it is we're trying to do with exponential functions, especially now with this natural base. It's a new thing. This is about all we do with it. When you get to pre-cal, college algebra, you may get a little more in depth with it, but that's what we need to know for now. So have a great day. Make sure you comment hi, get your stuff posted. Your Khan Academies, I think some are due tonight. The rest are due by Sunday, as long as that in that worksheet. And don't forget to comment on the YouTube videos, those awesome musical videos that I'm still waiting for some of you guys to make better ones. So I don't know what you're waiting for, but I haven't seen any yet. So I know you're probably just getting the finishing touches. So stay safe, stay clean, wash your hands. Alex is upset. She's in bed already, so she wasn't able to be in this video, but I'll find her later. So take it easy.